Hello everyone, and welcome to our webinar in conjunction with the Methane Guiding Principles, entitled Reducing Methane Emissions from the Oil and Gas Sector, Guidance for Improved Operations. The webinar will be presented by Matt Harrison and James Van Horn of SLR Consulting, and Dave Allen from the University of Texas at Austin. We'll let Matt, James, and Dave introduce themselves in a few moments. My name is Jim Herbertson. I'm the Technical Director for Climate and Energy here at IPECA. Before we start, I would like to cover a few housekeeping items. The webinar is being streamed through your computer, so there is no dial-in number. Everything you can see, including the slides, is resizable and movable, so feel free to move things around and get the most out of your screen. At the bottom of your screen, you will see some features that are available. You can use the Q&A box to ask questions as we go. Also, there is a help feature, but most issues can be sorted by refreshing the page using the F5 key. This is particularly useful if you think your slides are falling behind. A recording will be available later this week and can be accessed using the same link you are using now. And I'd like to say a few brief words about IPECA for those of you who are not familiar with the organization. IPECA was formed in 1974 following the launch of UNEP, the United Nations Environment Programme. We are the only global association for both the upstream and downstream oil and gas industry, and our membership operates worldwide, and we reach about 500 oil and gas companies when we include the reach of our association members. We are the industry's principal channel of communication with the UN and work closely with a number of UN bodies. We present and hold side events at the UNFCCC, the Framework Convention on Climate Change, and its COPs, the Conference of the Parties, and we have been doing so for over 25 years. At IPECA, our vision is to advance the oil and gas industry's environmental and social performance and its contribution to the energy transition and in the context of sustainable development. IPECA has been convening, educating, and informing our members on the topic of methane for a number of years. We have run workshops, published a methane glossary, carried out a methane mapping exercise, and most recently held a virtual workshop in November called Methane Science, Regulations, Voluntary Initiatives, and Global Expectations. All of this material is available on our website, and I encourage you to explore it. We are also proud to be a supporting organisation to the Methane Guiding Principles initiative. IPECA's vision is realised by convening our global membership and key stakeholders in order to develop good practice and tools which we share with the wider oil and gas industry and beyond. And where others have developed such tools on behalf of the industry, we look to communicate them more widely and raise awareness with our global membership. Hence our webinar today. Our moderator for the Q&A session, Mahanthan Satyamurthy. Sona is the Group Carbon Manager at BP and is Chair of the IPECA Task Force on Managing Methane Emissions. To you, Rebecca, to say a few words about the Methane Guiding Principles before handing over to Matt, James, and Dave. Rebecca, the floor is yours.
Thanks, Jim. And firstly, I would like to say a big thanks to IPECA for inviting the Methane Guiding Principles to present at this webinar. I'm going to talk really briefly because I do want to maximise your time hearing from Matt and Dave. Just a quick few words on the Methane Guiding Principles for those people that aren't familiar with our initiative. So we started out in 2017 and we have quickly grown. We're now an initiative of 39 different organizations. And so we've taken on a dedicated program manager, and that's me. And I think what makes the Methane Guiding Principles different and interesting is that we have a mix of different organizations. So we have companies, but we also have civil society representation. So supporting organizations like IPECA, but also the World Bank, EDF, the International Energy Agency, and so forth. So we also have a mix of representation across the gas value chain. So upstream, midstream, and downstream organizations all take part. And that's really effective in sharing of information and different perspectives to achieve a solution that works across the value chain. That's so important. And finally, we've got great regional representation as well. We're a global initiative. And so we do manage to reach various different and interesting parts of the world where, again, the challenges also are different and interesting. So that's probably all I am going to say for now. But if you do want more information on the methane guiding principles, do feel free to reach out to me. And with that, I will pass back and let's get into the meat of this. Thank you.
Okay, thank you, Rebecca. This is Matt Harrison. I'm with SLR International. And I'm going to kick this off just by saying the format, of course, we're going to go through these slides. You're going to hear from several speakers speaking to particular pieces of the methane guiding principles. And then, as mentioned, we'll have a Q&A session at the end in about 45 minutes. So we appreciate your attendance. And if you would just take your questions and plan for those for the Q&A session, we really look forward to that. So the agenda for today, of course, we'll do a quick introduction to the speakers that I'll show you. We're going to go through the best practice toolkit, the guides plus the cost model. We'll make mention of one other thing, which is gap assessment tool, but we're not intending to expound on that today. And we'll talk to you a little bit about construction of the guides and go through one guide in a little bit of detail to show you what's in there, and another guide in just a quick summary form, just as a couple of examples to show you what you might be able to get out of these guides. And then finally, one of the, I think will be a very interesting thing is a review of the interactive cost model tool before we get into the Q&A session. So your speakers today for going through the guides are myself, Matt Harrison, Dr. David Allen from University of Texas, and also my colleague, James Van Horn, that will be talking to the cost model. And of course, these slides will be available to you later. As you can see, there's contact information below each speaker. If you wanted to reach out to us after this session is complete, we're still glad to talk to you and answer questions. So let me go into now the introduction to the guides. I want to talk a minute just about who the intended audience is. And of course, it's you. If you're on this line and you're interested, we're intending the audience to be you. But really, we see this as something that operators globally would be able to pick up and gain some benefit from. So if someone that's a manager of a facility anywhere on the world along the natural gas supply chain should be able to pick up these guides and make use of them in terms of understanding the available technologies and what some of the options that they would have for stepping forward and improving and reducing emissions. So as you notice, we also put in a why. Why are these done? You know, the overall goal is to improve the state of knowledge and emissions from supply chain production to the final customer. As probably all of you are aware, you can just Google methane guiding principles and find this website, but we have put the web location of the guides in here. Within the methane guiding principles website, it's a simple click through to the best practice guides, and we'll show you what that looks like. There's also, of course, like any guide, it's was made at a certain point in time. And the very good news is that many things in controls and mitigation, detection, quantification do evolve over time, improve over time. And so there may be updates in the future that the methane guiding principle group considers to make those evolve. So I want to show you in the next slide just some of the icons. So when you click through to the site, you'll notice that that there's 10 guides now. There were 8 guides produced in 2019 and 2 more produced this year in 2020. They're shown with icons there, so you'll notice that in the upper left, there's the engineering and construction guide. I'll show you a slide in a few moments that has information with regards to how all these guides relate to each other. But if you were to click on to any one of these icons, you'll notice you can click to a synopsis, which is just a couple of pages overview. Something good if you were looking at it from communications with upper management, or an executive summary for someone that just wants to get an idea of what's in the guide quickly. And then you'll notice there's an English guide, and right now a Mandarin guide, and I believe there's some other translations being worked on. But basically you could look and see there's of the 8 there's engineering and design, flaring, energy use, equipment leaks, which has mostly to do with leaks from sealed surfaces, on equipment, screwed connections, flanges, pack surfaces, things that are normally the subject of leak detection and repair programs. There's also venting, so this would have to do with direct vents, intentional and otherwise, pneumatic devices, which mostly have to do with control systems that use natural gas as the power mechanism. If compressed air or electricity instead were being used to move control devices, then you don't have emissions. But there are other things as well, pneumatic pumps, for example. Operational repairs, which is closely linked to equipment leaks. In other words, if you find the leak, you want to repair it, but it also is a broader. And continual improvement. And then the new ones that were added this year were a guide on overall identification, detection, measurement, and quantification. So this is how do you find an emission, and how do you separate them from, some of the things is not only how do you find them, of course, you want to find the ones that were unintended so that you can address them and make repairs, but also how would you quantify those? There's a lot of techniques that overlap detection and quantification. And this guide gives an overview of what's being done in that area. And then a focus guide that looked at a lot of these previous guides that had particular focus to upstream in some areas. So this last guide's transmission, storage, LNG terminals, and distribution summarizes some of the mitigations being applied just in those particular segments of the industry. So let me jump then into, if you go to the site, one of the things you'll see is that there is an overall methane emissions brochure. It is a collection of these synopses that I showed you on the previous slide. And those synopses are the short summaries of each report. And within that, I just wanted to note that of course, you can go directly to that through that link provided there, but you can get there through the direct website. And the synopses, if you click into those, you'll see some of the same icons that were previously shown here. But what I'm showing you is not the synopses, but the summary of the synopses. So a synopsis of the synopses, if you will. But you could list, even at a higher level here, well, what's done in engineering, design, and construction. You're trying to systematically minimize the emissions through that design phase. And there's a few bullets given for each guide as to what is being done in each guide. So, for example, if you wanted to know what was covered in energy use, you can see these summary bullets here. The same for what is being done in reducing methane emissions from fugitives and wells. You can see the summary here. So again, this is a summary of the synopses. The synopses each are about 2 pages. They give you a checklist for things to look at for each for sources that fall under each of these categories. And then there's a report that follows these. So again, just as was covered previously, the same titles here. And in fact, in the next slide, just completes that set of 10. I do want to note that, as you might imagine, looking at these titles, well, there's overlap between these. Well, how do you separate leak detection repair from operational repairs, or what are the mitigations and sources in transmission storage terminals LNG? Wouldn't they overlap with some of these other specific source categories in guides? And the answer is absolutely yes. And we have a table that I'm displaying right now that just shares how those do overlap. I'm not going to go into that in detail, other than to say, if you look at each one of these rows, those are the guides. And then the columns are the sources in green and the mitigation measures in blue. And we realize that some of these sources cover everything, and some of them cover a few things. So for example, even just something simple like pneumatic devices in the first column, there's a report on that. But also pneumatic devices are covered down in the transmission storage, a particular one as well. And so there are overlaps. We don't think that means conflicts, but overlaps. So let me jump ahead now to the last couple of slides. I did want to mention that there are cost models that you're going to hear about today. There is a gap assessment tool that allows you to say, well, where am I on the spectrum of things? We're not going to go into the gap assessment tool today just because of brevity and wanting to get right to the Q&A session, but I just wanted to call to your attention that that is on the site, and you can use that if you're saying, well, I haven't looked at any of these before. How do I assess where I am on these? I still would recommend, even if you're using that gap assessment tool, that you do review at least a synopsis version of each of these reports as well. And of course, many of you on this line will have gone far, far down the road on these, and maybe even be testing some cutting edge techniques that aren't yet even part of the common use, and that's great. And so we realize there's people everywhere on the spectrum that might make use of these things, from just starting to expert. So let me now cover briefly the structure of the guides. So now I'm not talking about the synopses anymore, but the actual guide itself. So after the 2-page synopses, the guide itself is still a short document. Ideally, our goal was 15 to 20 pages. Some of them are a little bit longer than that. We looked for a consistent structure among all of these. So we've shown, one example of table of contents here, but we will show you 2 other guides that we'll go into in just a few minutes in a little more detail. And each guide describes, cost-effective approaches, case studies in some cases where possible, and has links to additional information. It's not meant to be the library of everything in the area, but it does have, if you are looking for more than just what are the listed recommended practices, but if you're looking for links to some of the others, background information, you can also find that in many of these guides. And as was mentioned, there's a synopsis. There's usually a checklist that also is summarized in an icon, both on the synopsis and in the report as well. And then, of course, we just have a cover for one of them. This happens to be the pneumatic device guide that we're showing. So with that, let me go to the last slide just to provide a little background on how these were assembled. It was not just by the people that you hear from today. In fact, we have, James and I have another colleague, Leslie Wong, that helped us write the continual improvement guide. But since we're not expounding on that guide today, she won't be speaking. But we did want to make sure that you realize, although there's a consultant team that helped with these guides, these went through a technical review with the MGP panel, and then also was put through extensive technical editing, both for a technical review point and and the plain English company that looked at it from a user standpoint, at least the English version that was produced first, and of course legal and copyright review before being issued. So we just wanted to point out that, of course, it went through a much larger team than it's not a product just from the 3 people that you're hearing from today, is my short point on that. So with that, let me turn it over to my colleague, Dr. David Allen, who's going to speak to, I say I was one slide behind there, sorry, who's going to speak to one of the guides that we're going to do as an example, the IDMQ guide. And Dave, with that, I'm going to advance to your first slide, and then you can take it from there, please, sir.
Great, thank you, Matt. So Matt gave you an overview of all the guides plus the cost model and the gap assessment tool. What we're going to do next is pick out a couple of the guides and give you a deeper dive into what the guides look like. We chose these 2 in particular because we thought that they might be of the broadest interest. So the first that you'll hear about is the guide dealing with what we've referred to by the acronym IDMQ for identification, detection, measurement, and quantification. So let's look behind the synopsis and the cover and see what these guides look like using these examples, the first of which is the IDMQ guide. So again, you can just get a brief sense of what's in this guide from the table of contents. So an overall summary, but a lot of the material in the guide focused on methods and case studies. And so let's take a look at how the guide is organized. As Matt noted, if you look on the website, you'll see these summaries of the guides, the synopsis of the synopsis, and here is that synopsis of the synopsis for the IDMQ guide. So how do we identify the I sources that are known? How do we detect them out in the field using surveys? How do we quantify them and get estimates of emissions using a variety of different measurements? Many of the guides attempt to summarize the thought flow in the guide through a diagram, and that's what we have here. And so what you'll see is that for IDMQ, the identification, detection, quantification, and measurement, we step through a process. All of these activities are typically parts of programs to reduce methane emissions. And the first thing we do is attempt to identify, and this might be both through surveys as well as through engineering assessments, what the potential sources might be. We then go out and detect using a variety of different methods that I'll give you examples of. We quantify, and different methods have different strengths and weaknesses on quantification, converting a detected emission source into a quantitative estimate of what the emission rate is, and that's done through a variety of different measurement technologies. And so what the guide focuses on is the material highlighted in green. So let's look at that part dealing with identification, detection, quantification, and measurement, specifically looking, as most of the guide is focused on these methods for making measurements, the methods for detection and quantification. And what the guide points out is that these occur at a variety of different scales, both spatial scales and temporal scales, and they occur on a variety of different platforms. We can do these surveys to detect emissions by foot. We could have fixed site measurements. We could have ground vehicles on which measurement technologies are mounted. We could have drones. We could have aircraft. we could have satellite measurements, and all these operate at different spatial resolutions that you see represented on this conceptual map, as well as temporal resolutions. And the guide deals with all of these. And so we have a variety of different sensor types as well associated with these platforms. So there could be point measurements that get made, open path measurements that get made, various types of imaging that gets done. And so the guide summarizes that there are a number of these different sensor types that could be applied on various different types of platforms to give us various different methods for making measurements and doing quantification. The guides go through case studies of those methodologies that have been applied in the field. This is a fast-moving area, the IDMQ area, and so what we focused on in the guide is developing case studies in the guide that highlight methods that have been applied in the field in operating circumstances. So I'm just going to give you a few examples of this. These are highlighted in more detail in the guides, but we'll give just a few examples of the multiple examples that are highlighted in the guides. For in operator-based deployment, I'll briefly describe the high-flow sampler. For fixed site measurements, there are a variety of methods that are used. For wheeled vehicles, again, a variety of methods are used. I'll just give one example, a brief example of a drone-mounted system, and then brief aircraft and satellite-based methods. So let's just look quickly at these methods. The guides explain these in detail, and so I'm just going to give you the highlights in these. And if you're interested, you can go to the guide and extract the information from the guide. So the guide will for each of the methods describe the technique. So those of you who are familiar with the high flow sampler, you'll know that it's a backpack mountable, intrinsically safe and battery operated instrument that draws air into the instrument at known rates. It has a detector, and that detector is used to develop a measurement of the emissions that are, in terms of the emission rate, that is drawn into the sampler. And so it provides a quantitative estimate of the emission rate, and it's been used in the field for decades. Recently, there have been questions about its quantification that have been resolved, and all of that is described in the guide. Also, there are optical gas imaging methods that are used. So an imaging method on foot, and here you see that being deployed in a number of different types of environments. And so this method is particularly used for detecting emissions, but a variety of methods have emerged for quantifying emissions using this optical gas imaging system, which detects emissions in the infrared. Again, algorithms are used to post-process the images generated by the camera to develop quantification. And there are a variety of studies that have been done that the guides describe that establish the detection limits for this. And each of the methods is also summarized in terms of its cost. Another example is downwind measurements of plumes from sites, and a variety of methods as well are available here. This one describes a downwind tracer method where a tracer is released on site, and the downwind sensor, typically mounted on a vehicle, detects both the methane being emitted as well as the tracer, and from that you get quantification, again, emission detection limits reported, costs reported for various types of case studies. More and more emerging methods are appearing. A number of your organizations may be testing out drones, and we summarize some inner comparisons of the drone mounted equipment. The one shown here is for a device that uses an infrared-based sensor, and these can detect quite low emission rates. And we give estimates on costs based on preliminary deployments. Finally, I'll give just two more quick examples. This one on one of several types of aircraft-based methods that are available. In this case, the aircraft, as shown on this diagram, flies spirals around a site. You can see color-coded methane concentrations detected by the aircraft as it spirals around a site. From the upwind and downwind measurements of the wind speeds together with the concentrations, a site total mass emission flux can be calculated from this type of measurement. And again, we provide information related to cost and quantification limits. There are also aircraft methods based on light detection and ranging that are described. And finally, there are fixed site sensors and satellite-based methods. Satellite-based methods include both thermal imaging methods used to detect, for example, flaring, as well as an emerging group of methane satellites, which are rapidly evolving in their sensitivity. So the guide summarizes all these. It's a bit longer than many of the other guides because of the diversity of methods that are being used. So after having summarized these different quantification methods and measurement techniques, what we then do is briefly summarize in the guide that frequently what's done is to put these measurements and quantifications in the context of an overall program where the IDMQ, the identification, detection, quantification, and measurement, is deployed on a regular basis. The methods are continually updated, and the information about emission rates and quantification hopefully shows continuing progress. So this is a snapshot of one of the guides. I've gone through this very quickly. The detailed information is available in the guides. And so what I'm going to do next is turn it back to Matt in just a moment as I go to the next slide. And Matt will talk about the leaks. Matt.
Yes, sir. Thank you, David. So now I'm going to go through in a little bit more cursory fashion, but the leaks guide, just so we have kind of walked you through a couple of them in more detail than just what was in the synopsis. So you see the cover here of the leaks guide, which you would also see if you went to the MGP site and downloaded the file. This was one of the original 8 produced in 2019. Again, as Dave mentioned, kind of the synopsis of the synopsis appears here. You know, it's talking, what we're going to talk about in the leaks guide is how companies are systematically performing and what recommended practices are in systematically performing inspections for fugitive emissions, and what we're calling those, in this case, synonymous with equipment leak emissions. That term fugitive emissions is applied broadly to things that enter the air, including sometimes it includes everything, including vented sources. But what we're talking about is from equipment leak sources when we talk fugitives here. So how do you build your fugitive inspection repair capability and skills, including operator discipline? In other words, there's key parts of what is in a good fugitive program. and what are the technologies that can be used. And then finally, how you could even look at it separately than the leak detection and repair program as to how you use modern high integrity materials joining technology when you're actually doing the construction of networks, so that you have less sources that could leak to begin with. And that's also overlapped, if you will, to the engineering design approach. So let me continue on through this quick example. Just wanted to show, again, it's got a similar table of contents to others, just has a summary introduction, quantifying emissions from leaks, what the mitigation strategies are. Finally, wraps that up with a checklist, and then gives references after the appendix materials. So when you're looking at quantifying these leaks, first you're identifying them, of course. And there's a number of ways then, once you've identified them for repair, that if you wanted to quantify them, you could step in to do that. I'm not going to go into each of these in detail, but of course you can quantify by just site population. I have a certain number of industrial customer meters of a certain type and pressure range, and we have an emission factor for that. That's one approach. You can quantify by equipment population. So you could take that same, let's say, industrial meter set and say, well, what's in there? Well, I have a certain number of valves, and I have a certain number of pressure regulators, and I have a certain number of meters, and there could be connectors, flanges, pressure relief valves. We could have emission factors for each one of those things that go down to quantify by component. You could also have this intermediate one where you look at a large site like a gas processing plant and do it by the number of major equipment processes. So those are some approaches to quantifying that are discussed within the manual. And in general, of course, the manual is looking at, as was mentioned earlier, it's part of what's typically been called a leak detection and repair program. You'll notice there's no Q in leak detection and repair, although there is, as was on the previous slide, some discussion of how you might do the Q. Q being quantification or determination of rate of the emission, rather than just identification of the emission location for repair. And that has overlap with the IDMQ that Dave just talked about. And of course, in addition to periodic programs, there are some alternative programs being considered in different areas. How could you maybe increase the number of large-scale surveys you do and decrease the number of human power intensive on-foot surveys needed to be done? In other words, how do you find the biggest things fastest and make those repairs? And because that may be more important than finding all the tiny things in some cases. This is where, of course, regulatory jurisdictional would allow such a switch. And there are cases like that. Canada is an example that's looking at that carefully. And then, of course, as we mentioned, minimizing components that leak. So with that, let me take it back to the next step, which I think is going to be very interesting, and turn it over to my colleague, James Van Horn, who is going to talk to the cost model tool. And James, if you want to take it from there.
Thanks, Matt. So, part of this toolkit is also some cost models, and the purpose of these cost models is really a diagnostic tool, to give you an idea of what mitigation strategies should be explored further. Now, the caveat with these models is they shouldn't be used as a decision-making tool in and of themselves, although I believe that they are pretty powerful for at least a first cut in trying to identify some of those potential mitigation options. So we've designed the cost model to be, to be used by anybody who has knowledge of a facility. It doesn't have to be an engineer. And as I'll show in a second, there's not a lot of required inputs, although you can really dive in and get a lot of regional and company specific information in there. So, as I said, there's actually very few required inputs, which I'm going to show you in a minute. I was hoping to do a live session with this. It was difficult, and there was too much lag on showing it, so I'm going to do some. Use some historical costs and try and bring them into today's dollars. So whatever you're using these.
James, we're losing your audio somewhat. You might turn off your camera and see if that helps with your bandwidth.
Matt, I'm still not getting a connection. Do you want to take over for James?
Yeah, sure. And James, if you come back in, just stop me. The cost model tool, as James started out talking about here, is an interactive product. So it's not, while there's a workbook that he's displaying right here, it is a product that you download and you can put your own data into. And as he was starting to cover, you can, by putting your own data, you can, as the second bullet shows there, you have the ability to override defaults. So we've got, default data in there, but if you were looking at a location in Algeria and said, well, our cost for labor, our cost for these particular things is much different than was assumed, that can all be replaced. The tool does account for both capital and annual operating costs. It accounts for certain elements that have to do with feasibility, like whether power is available or not. So it's interactive and asks you to input responses to those questions. And then ultimately, of course, it recommends a mitigation and gives you a cost effectiveness in dollars per ton reduced for a particular mitigation option that you are looking at. It doesn't convert methane to CO2 or secondary emissions. And of course, a lot of the costs, like I mentioned, are default to North America. And so it would be appropriate for someone to go back through and substitute, as that second bullet says, for other regions. I believe James had inserted several slides here that had to do with examples of the tabs that you hit when you come in to look at what's being done. You'll see that you're given introduction and background on this slide, and specific instructions as to where you go and what you do when you're running output from it. So it's not just if you will, we've all dealt with maybe a very large spreadsheet or database tool with no instructions, and almost need a seance to figure out what to put where. It does have some instructions that go with it. And then I believe James has some examples, templates of things that were put in. And by the way, as James mentioned in the beginning, our initial intent was to actually walk you through an example interactively. But because of the lag time between displaying something interactive on here, these are just done in a slide deck format. But the tool is quick to respond. It's just the only reason we're doing this is not because of the lag of the tool, it's because of the lag of the webinar function. So you can see on this, it gives you some inputs. You're dealing with what monetary system you're doing, even natural gas prices, and it offers some lookup tables. The facility information you're looking at, including number of them, so that when you get a response out that, it applies to that segment of it. And then continuing on for his other inputs. And hopefully we'll get him back here to make any overview points. You can see it even has general inputs having to do with, as we mentioned, currency and costs and prices, especially for things that affect cost of a solution, like power costs and natural gas costs. And then all the way down to where, for a particular example, by the way, this is done for certain mitigations. And what I mean by that is not every single mitigation and every single manual it is in the cost tool, but there is a set of them that are in the cost tool. And so within that, then it asks for details on what the description of your operating system. Finally, then I think what he was showing is there are some optional inputs that you can put in as well. These help refine them. What it's got is the default sources over here in blue, and then but things that shows where that is, and then what the source for that is from when you're going to use it. Then on the next slide, he's actually got what it looks like when you're using the cost model. And it would give you, for example, in this particular case, for compressor emission results, what your options are. And you can see in that little pie chart that's a circle, compressor blowdowns, engine starters, reciprocating compressors, changes, natural gas fired engine, what your tons of CO2e per year contributing from each of those sources are, and then ultimately getting over to something that gives you a cost reply for each of those mitigation options. The next slide, the next couple of slides, it'll be the last of the set, which give you output from this, produces what is many of you have seen before called a marginal abatement cost curve. And so once you've input all your data, now your output is, well, what are your steps from things that have a positive return on investment, which is a negative cost on this chart, to things that have a cost, and they the width of them affects how much how many tons they affect, and the net cost, of course, is on this y-axis, and the cost effectiveness in dollars per ton of CO2e reduced. And there's a couple of different ways of presenting that for you to look at what's been done there. So, for example, within the compressors model, you're looking at, do you install changes to the catalyst and AFR? Do you, replace electric driver or gas engine drivers with electric power? It's a high cost, high capital cost, but takes things from having emissions to no emissions. And do you route the reciprocating compressor rod packing to flare, all the way down to converting engine starters, which may be just using gas and venting that to the air, all the way down to how you handle blowdowns. And so there's annual costs, operating costs that are presented in this. What we're showing is the outputs or the results from the cost model. And I think that concludes, there are calculations, as I think James is showing here on this last page, calculation backups if you want to know, well, wait a minute, how'd you get that? So there's calculation backups for any of these that you see. And hopefully James is able to join us again for the Q&A session, but that wraps up the discussion of the cost model. So Sana, if okay with you, why don't we turn over to you for the Q&A session, and we will ask you to summarize either what's coming in through the chat or whatever people want to do on open mic there. And Dave and I will give our best answers to that. And if James is back, he will also. James, are you back online? Okay, if not, let me turn it over to Sana.
Yep. Thank you, everyone, and thank you to the obviously Matt, James, and David for an informative set of explanations in the confined time that we have. We do have a series of questions, and these are in no particular order. I've tried to theme them, but no particular order, and we should have enough time to get through them. I guess the first question was your thoughts, I guess, to any of the speakers, your thoughts on thermal oxidizers and combustors and what role they have in terms of reducing methane, and are they covered in the guides, for example?
Yes, there is an entire flaring guide, so I'm sure that Dave will be the right person to respond to that. But I'll just say overall, of course, they have a huge role. Because as everyone knows, methane, you have a much higher global warming potential for methane than for converting that same molecule to CO2, where you've got a CO2 equivalence of 1. So it's very important if a methane were to be released to the atmosphere, thermal oxidizers and or even open flares are very important tools in controlling and reducing the impact from the methane release from those sources, and even down to proper operation of those, because of course you can have a control device and nothing has a 100% perfect service factor. So there's issues there. Dave, since you wrote the flaring manual, would you like to add anything to that?
Sure, I'll add just a little bit, Matt. First, what the flaring guide does is first just summarize what we know about the quantities of material flaring and what its geographical distribution around the world is. And then what the guide goes through is a sequence of tiered operations that can be used first to, and have been used and demonstrated, to capture gases that would otherwise be flared, to reduce the volume of gases that might otherwise be flared. And then for those gases where the best choice really is still to continue to flare the devices, what do we know about making sure that flares continue to operate and combust the gases as effectively as possible? So for flares, there's all of that. More broadly thinking about thermal oxidizers, you can have thermal oxidizers that you wouldn't necessarily consider as a flare, and those are described a bit in the engineering guide.
Cool. No, thank you, Dave. I guess the next question, probably a yes/no answer to start with, and then it will feed into the question after. Do the guides cover subsea? I'm paraphrasing a little bit. Subsea methane, the underground part, or is it only the top sides we're looking at?
Yeah, let me take the first crack at that. Really, we're talking about the top side. So if you had methane emitted from subsurface, let's say a formation that has some path to the surface, that could be a natural path. So you could have coal bed methane emissions, or you could have formation seepage. We do not address that in these manuals. This is mostly the natural gas supply chain. So the equipment that's been put in place to produce it from the ground, and once it's inside that equipment, how it gets ultimately to the customer. So it addresses that chain of equipment.
Cool. And that's a great answer, Matt, and thank you. And that leads me to the next question. There are 10 guides. I guess in your view, are there any guides that are needed, that are material, interesting, useful, and beneficial to governments, regulators, industry?
These have a good breadth, and if you noticed on that one slide I put up that had overlap, or not overlap, but cross-referencing between the guides, you can see that it covers a lot of area. I will say that if you picked just a particular facility within a particular segment, there's always the chances that someone could say, well, I want something more specific to, and I'm just going to pick something random, customer meters and distribution. I don't want to have to extract it from all these guides. I want to just have something that focuses on that. Now, I'm not suggesting that that's needed, but if someone decided that was a key focus area, that could be done. For example, this year we assembled the transmission, storage, LNG distribution guide, which some of that material had been previously covered but spread across the other guides. But for those segments, it was felt it was useful to pull them together because they have some unique things that are different from production, gathering and boosting, gas processing, that are unique to those segments. And I would think more so than an area that's missing, updates are going to be important, especially in areas like IDMQ, identification, detection, measurement, and quantification, that are quickly evolving.
Cool. No, thank you. I'm going to join a couple of questions together, and not just because they're quite detailed questions. I think they're covering a common issue. So I guess I'll phrase it. What are your thoughts on the reconciliation challenges between bottom up and top down? How complex, how doable, how variable, and then linked to that. And maybe that's part of your answer. As we move forward, can we, or are these able to be, mapped to, verification parties, third parties, and to international standards and ISO protocols? So how big is that journey? Is it ready? Is it almost there? Or is it in the to-do box and it's complicated?
All right, I'll go ahead and take a first stab at that.
Thank you, Dave.
I'll focus initially on top-down versus bottom-up, and then maybe you can deal with the second part question about how this intersects with standards. And I would say that in North America, there's been a big effort over the last 5 or 6 years trying to reconcile very detailed measurements and quantification that are done bottom up. In other words, going to very specific sources and making inner comparisons, and then comparing them to top-down measurements that might be from, typically they've been over the last several years from aircraft-based platforms that might, for example, attempt to get emissions over an entire production basin, but equally well could be downwind measurements that make a measurement for an entire facility and trying to reconcile that with individual measurements that get done within the facility. So that's what we mean by the top-down versus bottom-up. One of the learnings from North America has been that you need to be really careful in doing this and very diligent in assembling the inventory that you're comparing to these top-down measurements. And so many of these top-down measurements are instantaneous snapshots. You're flying an aircraft on an afternoon and you're getting a snapshot of what the emissions are at some given instant in time. And what we know, particularly for the upstream sources, is that there's a lot of spatial and temporal variability in what these emissions are. And you need to carefully match what the top-down measurement is telling you with what the activity is going on in these sources that have a lot of variability in emissions that might be due to compressor blowdowns or a liquid unloading at a well site or something else. If those are done very diligently and very thoroughly, then what's been found in North America is you can do a top-down versus bottom-up reconciliation. And you learn a lot from doing that reconciliation. And so, in fact, one of the points that the IDMQ guide makes is that doing that reconciliation can be a valuable part of the overall process. And I think that we'll continue to see that being an issue as more and more satellites get launched and other top-down measurement information becomes available. So let me see if Matt wants to add anything to that fairly extended answer.
First, I love the question. And I think that we could spend an hour talking just about that separate question. It's the most interesting question. In addition to what Dave said about that there are ways to reconcile things once temporal and spatial variability are considered versus a snapshot in time from perhaps a top-down measurement, I think we do see the industry not sliding, that's the wrong word, moving more towards closer to continuous measurements in some areas. We're just going to see more measurements. We're going to see satellite measurements. We're going to see systems of continuous monitoring set up in some areas, not across the world everywhere, but you're just going to see more data that looks less like a snapshot and more like a higher frequency of data. And that's going to help us determine, are there some of these temporally missing sources that just hadn't been appropriately accounted for in the existing inventories? Because that's been the contention is, top down produces an estimate here and bottom up here, and why is top down higher and bottom up lower? Sometimes that's just the temporal spatial considerations if you overfly when the events are occurring and apply it to 24/7. And sometimes that's because the bottom up didn't have every piece that's needed in the inventory, which we'll get, I think, as we move to more continuous. Asana, I think your other part of that question was having to do with standards and intersection with standards. Is that right?
Correct. ISO 14064, for example.
Yeah. Well, there's many things coming out. The OGMP Framework 2.0, even thought-leading white papers like EDF's Hitting the Mark paper, which suggested that companies that are doing very good, proper inventories and participate in voluntary programs still ought to be doing independent measurements and verifications that kind of get to, at least at a sample set of facility level top-down measurements for verification. And then I think we're seeing some standards, as you're mentioning, but we're also seeing pressure from investor groups that want to see a common language for talking about methane intensities and ways of intercomparing companies that they're investing in. And so I think all of those are going to push an intersection for a need for a common language and in some cases a common standard.
Cool. Thank you, Matt. Thank you, Dave. I know we're over time. I'm going to see if I can squeeze in two questions. I think the first one's a quick one. The second one builds on a little bit of this conversation. So the easy one, I hope, is can you download the cost model? The cost tool that's on the MGP website, can it be downloaded and used?
Yep.
Yes.
Yep. They're free to download and be used. Yep.
Perfect. Thank you. So then the next question is linked to, again, down to the conversation around drones, aircraft, even sensors. Some of them, I guess, for smaller operators and smaller companies, they can be cost prohibitive, certainly at the moment, and we know there's a lot of development on that. So how can they utilize what's available, or do they have to wait until the cost point is lower?
Well, I think that what the IDMQ guide gives smaller operators is a window into what we know so far about what these technologies are capable of producing. This is a very fast-moving area where there's a lot going on, and I would say keeping current with what the industry as a whole is doing to advance IDMQ, identification, detection, quantification, and measurement is an important thing to do. And the methane guiding principles documents give you a window at this point in time into what the status is.
Cool, thank you. So there are a few other questions, again, on the interest of time, and we are over. So what we'll propose to do, Jim, I think, is take those questions and develop some responses and share that either with the group or with the individuals that raised, or both. Is that right, Jim?
Yeah, that's fine. We can do that. Thank you, Sona. Okay. A huge thanks to Matt, to Jason and Dave, our presenters today, and for answering so many and such a wide range of questions. Many thanks to Rebecca and the Methane Guiding Principles for the opportunity to communicate more widely with our members these excellent guidance documents and the work that the MGP is doing. Remember, the guides will be translated into several languages: Russian, Arabic, Spanish, and French. So please look out for them on the Methane Guiding Principles website. Thanks to Sona for moderating the Q&A session. And thanks to all of you on the line, and apologies for running over a bit. I hope you found it was worth it. As mentioned earlier, a recording of this webinar will be available in the next couple of days, along with a copy of the slides, and it can be accessed on the same link as the live webinar. So thanks again to everyone. Have a great rest of the week, and please stay safe. Thank you, and goodbye.
Thank you. Thank you all.
Thank you.